Hi, sorry for the delay. Good evening, everyone.
Good evening, sir.
Yeah. Okay. So today is solve with us for week 9 session, right? This week we'll have two revision sessions. Maybe I'll just uh, I'll- so one revision session will happen on Thursday, which is revision session 1 for okay. So that revision session will happen from 8 to 10 on Thursday as the usual timings. I wanted to know that whether it will be fine to have one more revision session on on Friday. Is that fine?
Yes, sir.
Just a minute. I'm just adding one more session there. On 27th September, we'll have the session from 8 p.m. to 10 p.m. That will be your revision session 2. Think. Can anyone of you can check on the on your calendar that whether it is available for you to see there? Are you able to see the session on your calendar?
27th,
Yeah,
sir.
it is
Yeah.
available for 28th.
28 is okay. Sorry, 29. 29. Are you able to see
No,
that?
sir.
No,
No.
sir, not yet.
Okay, 1 minute. I'll just 29th. We have to keep it right. Okay. So I'll just change it to 29th of December from 8 to 10 p.m. is okay, right? 8 to 10 p.m. and this will be vision session 2 for quiz 2. Okay, fine, nice. Uh, okay, can you just okay? Still, it's not visible, right?
Sir, it is 29th November, not December.
Oh, it goes to December, huh? Sure. No, I didn't do that. I guess. Okay, that's okay. I'll just add it later on. Fine. So, but I think that it will work, right? So, maybe 22nd November. Can any one of you now check 29th if it is available? Is it visible for you in your calendar?
No, sir.
Sir, it is visible for 29th December, not 29th November.
29th December. Ah, no, no, that is okay. So that is Sunday, right? We don't have to worry about Sunday. Okay, I'll just see you. I think there is some. I'm not able to do it. Might be okay. Maybe I'll do it later on.
So there
Fine.
is a session on 29th December actually, and it is timed. It says quiz 2, MLF revision, so session 2.
That's what it's there, right? 28th. Are you able to see it? That's what I'm
No, no,
asking.
sir, to 29th December it is.
No, no,
The date.
29th November. November.
No, sir. November there is no session on, I mean, 29th, but there is a session on 29th December.
That is okay. That is already in there. I'm not worried about 29th December. That is on Sunday, right? I'm not
Yes,
talking
sir.
about Sunday. I'm just talking about Friday session. This Friday, coming Friday. Because we need to have two sessions for quiz two revisions, right? So that's what. Okay, we'll do it later. No issues. Uh, okay, so today is week 9 revision session. I hope I don't know how many of you have been prepared for this, but we don't have much time after quiz two, so we'll have to conduct the session, right? I think the deadline for submission is today, right? For week 9 assignment.
Yes, sir.
Okay, fine. So are you able to see my screen now?
Yep.
Okay, please join the joinpd.com or peerdeck and use this code to join in. It is AXYXCF. I'll just paste that code into the chat box as well. Okay, so yeah, still. Okay, so please, all of you, please, those who have joined here, please join in using this code. I can see at least 10 members are there in this meeting, apart from me. So I hope you can just join in the joinpd.com, like type in joinpd.com or use peer deck. So you can join the session, right? And use that code as AXYXCF. Not very difficult questions are there from week 9. Okay, so I hope you all of you understood what is unconstrained optimization and constraint optimization. The questions are today's sessions questions, right? So they are based on convex, like what is the convexity, what is convex hull, right? On those basis, right? So I hope you know what is Hessian matrix, and if it is positive semi-definite matrix, then what we can say about that function? We can say that if it is two variable function or more than two, right? In that case, the Hessian matrix is semi-definite matrix. Then in that case, we can say that that function is what? Convex function, right? That is like there are four definitions. Out of those four definitions, one of the definitions which can be mathematically we can see it. Otherwise epigraph of function is also there. I think one more thing is like there are two other definitions are there, but yeah, so mathematically they're not much useful, right? So uh, for the sake of questions, I'm just telling you guys about those. So mostly the questions will be based on that. Okay, so let us try to finish as soon as possible, so that okay, so yeah, so the questions will be shared on the screen. 3 to 5 minutes will be given to solve the questions, and you can share your answers in the. So it's not there, so you do not share the answers into the chat box. You just paste it into or type it into the joinpd.com or peer deck. Okay, yeah. So let's start with the first question. The question is what? Question is, what will be the constraint equation for the case when you have maximum 3 hours of time to solve whole question paper? If it takes 10 minutes to solve a MLF problem, 12 minutes to solve a mathematics problem, and 5 minutes to solve one English question. Okay, so you have like entirely you have 3 hours of time. Okay, and there are you know 10, if there are the questions based on machine learning foundations, mathematics, and English question from these three courses, you know that there is only one question. Sorry, so to answer one question from MLF, you need 10 minutes of time. For mathematics, you'll need 12 minutes, and those are denoted by X, Y, and Z. Right. So these are the three random variables, or three variables I can say. They denote MLF, mathematics, and English respectively. You need 5 minutes of time to solve the English question, maximum of 3 hours. So what will be the constraint equation in this case? Right.
Hello,
So
sir.
yeah,
Sorry to interrupt. Actually,
yeah.
I'm not able to change the option. I mistakenly took the wrong option.
I think you can, right? So I think you can just tick on the other option. Try it
No,
like
sir,
that.
it is not like giving me that option.
Okay, no issues, no issues. Leave it that way. So I cannot do right now anything, right? So because it's already been published to you, so I cannot change midway. Okay, it's okay, no issues. Maybe we can see that later on. Hmm? Okay, just give me a minute. Okay, so I think those 6 students who joined this joinpd.com, they have answered into the that box. So let us see the answers first. Okay, so I think it's 3 students have are read for B and 3 for C. What you have written? Which one you have like? I don't know. C, right, Akash? Okay. So
Sir,
you're
actually, I gave option B, but the answer should be
okay.
C.
So we can say that now. So like including your answers, maybe 2 are chosen for B and 4 students have chosen for C, right? And we need to see that which will be the correct answer, right? Okay, let us see
Yes.
now. Uh, I hope you are able to see my screen now. So let us see the
Yes.
solution for this problem. Okay. Yeah. So first of all, what is the so in case of constraint or unconstrained optimization, uh, what what is the scenario generally is, or maybe what is the general form of this is like you'll have one function, right? Function of maybe x, y, z, something like that. I'll just say the function, and what we wanted to do, we wanted to minimize. So optimization problem is for minimizing for the values of x, y, or z maybe, right, for the given function, and this function is called as what? Objective function, right? Objective function. And what we'll have? I think one of the lectures we have seen this also, right? During maybe, I think when I was teaching you about one of the open sessions, I think week 8. Okay, so f is an objective function, and what are the constraints? So suppose there are two types of constraint. Let's say g of x. Uh, these are called what? Inequality constraints, right? And let's say h of x. X, maybe you can say that it can have the variables, more than one variables. Okay, so I'm just, maybe we can just make it simpler. So h of x is quality constraint, right? So these are the things which are already there in a general form. What we have asked in this is uh, question is first of all, what is the objective function here? To maximize or to maximize the time duration, right? So, or how to utilize the time duration. That should be my what objective function here, right? So if I have uh, total time, so we can have as like you wanted to solve the paper as soon as possible. That should be my objective function here. But the constraint, we need to find it out. So what should be the constraint here? So for one question of MLF, how much time it takes? 10 minutes, right? So if I wanted to uh, see this problem in terms of minutes only, so I'll say that 10x plus x is what? X is what here?
Still variables or
Yeah, but
number of
what are the
questions.
number of MLF questions, right?
Yes, sir.
Right. So how many number of questions you can solve within that stipulated amount of time, right? So we are trying to uh, get into the equation, right? So, and here y is what? Number of maths question. And we know that each question takes 10 minutes of time. So 10 into x is what? Total amount of time taken to solve the that many number of questions. So if you have, let's say, variety of questions, and how will you utilize the time to, so, and what is the maximum time you will have? So maximum time is,
3 hours or 180 minutes.
yeah, so it is 3 hours, right? So maximum time is 3 hours. So, and if I convert it into the minutes, it will be 180 minutes. So 12x plus 10, sorry, 10x plus 12y into 5z, it should be what? It should be less than or equal to. So either all of these questions you have solved, we don't know how many questions you are going to solve, but let's say you're going to solve x, y, z questions. And you know that each question, right? So each question of x, that is MLF, you need like what? 10 minutes of time. Each question of maths, you need to take like 12 minutes to solve, and 5 minutes to solve any English question. So the maximum time it can go up to how much? 180. So this is one of the constraints of mine. If I wanted to make it into the hours, what it will be? So each question of MLF can be uh,
Each time the constraint can be
10 by
divided by 60.
60, right? So it will be 1 by 6. So if I can say 1 by 6 is almost like 0.1667, right? X plus 12 by 60 is 1 by 5, which is 0.2 y. 5 by 60 is how much? Oh, sorry. Is it 5 by 60 is 1 by 12? Huh? Yeah, 1 by 12. So it can be how much it is? 12 point. Again, it will be very less, right? Okay, maybe I'll just do, let's say, 1 by 12 times z should be less than or equal to. So here it will be 3 or 180.
3.
3, right? So either this is correct or this is correct. And this is what? These both are what? They are the constraints, right? It's a constraint equation. So which will be here? I think option B looks no, option C looks correct, right? Because if I go with the minutes, 10 minutes, 12 minutes, and 5 minutes, then the maximum time should be 180 minutes, right? So option C is the correct answer. So those who have chosen for option C, it's correct. Maybe those who have chosen for B, they have considered the units, right? So there you have done the mistake. So you considered 10 minutes, 12 minutes, and 5 minutes one side. It cannot be same, right? So if you have left hand side in minutes, the unit on the right hand side should also be the same. So you, whenever you are solving these kind of problems, you have to keep that in mind. Whatever unit for any quantity you're taking on the left side, it should be same on the right side, or you have to convert. If it is not same, in this case it was not same, right? It was 3 hours of time given, but for each question it was 10 minutes. So we have converted that 3 hours into 180 minutes. Okay. Okay, so let's go for the next question. So this is a question. It says there are these 4 points 0, 0, 0, 2, 2, 2, and 2, 0. They form a convex hull. Which of the following points are the part of this convex hull? You know what is convex hull, right? What is convex hull? You had an open session, right, last time? Have you? Okay, whatever the whatever answers comes in your mind, that is fine. What do you think is a convex hull?
Sir,
Yeah,
it
all the
is a
points that are in the convex set. I mean,
Okay, okay, that is correct. Okay, let's say
if
maybe
you
you
join
converted.
all the points, it makes a border, and the points falling on that inside that border, that are the points of that convex hull.
Set of convex combination.
Yeah, it's a convex combination of all the points. So all convex combinations of all the points inside that hull, right? What? They are convex, right? So they will follow the convexity, right? So all the points on that hull is kind of, what you can say that. So these 4 points you can see, right? So these 4 points, if you take any combinations of all these 4 points, right, and you'll change the lambdas, right? So what are the convex combinations here? So suppose you have these points, right? So maybe I can say x1, x2, x3, and x4. These are the points, right? Suppose, how can I say that these are the points which are the convexes? So there is a convex combination which is, let's say, lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 plus lambda 4 x4. And what are the properties of these lambdas? They are, what is it? They should be,
it up to 1 and more than 0.
right? So more than 0, or it can be 0 also. It can be 0 also, right?
Yes, it can be 0 also.
It can be 1. So between that range. And what else is there? So this lambda 1 plus lambda 2 plus lambda 3 plus lambda 4, it should be equal to
One.
1,
1,
right?
sir.
Yeah. So if these conditions are satisfied, and if you take all the combinations of this, right? So it can be, let's say, 0.1 times x1 plus 0.2 times x2 plus 0.3 times x3. So how much it is? 325,516 plus 0.4 times x4. If I take that combination, so it will be 1 point, right? It will be 1 point. And let's say if this is a convex hull, so this combination, this, let's say I'm calling it as Z1, it will fall somewhere here, right? Suppose. So if you take all these combinations, they all should be falling uh, within that zone, right? Which is prepared by this convex, or these 4 points, and they all are what? They all are convex. Fine. Okay. So now, if you understand that point, then just try to see that which of these points are the part of the convex hull. So what I said is the points should not go outside that boundary, right? So whatever the boundary it is creating, all these 4 points, boundary in the sense each point, uh, you know, it will be let's say there are 2 points, they should join one, they should be joined through one line, right? So yeah, so in this case it's 0 0 0 2 2 2 and 2 0. They should, I think they should form a square, right? And the points of the convex hull, they should always lie within that square. So take that hint and maybe you can try to solve. I can see only 4 students have responded. Okay, anybody who's joined late, they can use joinpd.com, and this is the code for joining it, AXYXCF. Please join through it. Uh, okay, so out of the 6, I can see only 4. Are you guys trying or shall we move? Uh, I think this is very simple question, right? So maybe we shouldn't give that much time to this. It's very easy, right? Can you tell me what should be the answer?
Said D.
It should be D, right? Because -1 minus 0.5, if I wanted to show you this on the, oh, okay, so I think it's 0 0 here, maybe. Okay, I'll do it another way. So suppose you have this XY coordinate system. Where is 0 0? 0 0 is this point. Then what is the another point? 0 2. 0 2 will be here, right? 0 2. 2 0 will be here, and 2 2 is here, right? So if I join these lines or join these points through the lines, this portion, right, this entire portion uh, will be a convex hull. Okay, and if I take all the combinations of these 4 points, right, uh, or all convex combinations of these 4 points, they all lie within this square. So you can see that this is the first quadrant of it, right? So that means all the points which are positive, uh, they only should be, or positive in the sense, or those points who are lie into the first quadrant, they only can be the part of this convex hull. So in our problem, if you see -1 minus 0.5, it will, where it will lie. So -1, I think -1 here, and 0.5, let's say here. So it will be somewhere here. So it is not a part of convex hull, right? Only 1 1, this 1 1, which is which can be, midway of this, right? So this point is only the part of convex hull. Fine. Okay, so I think option D is the correct option. Maybe we'll move to the next question. Again, given S is a convex set, you know that S is a convex set, and the points x1, x2, x3, and x4, they belongs to convex set. Which of the following points must be the part of the convex hull formed by these points? Okay, so S is a convex set, and these are the points x1, x2, x3, and x4. They are the part of that. They belongs to that convex set. Which of the points must be the part of convex hull? I think already I have answered to that question. You just have to, uh, what is the condition? The
Said sum of lambda should be 1.
sum of lambda should be 1, and each lambda should be greater than,
Between 0 and 1.
Positive.
yeah, it should be positive, right? So let's see the first option. maybe I'll just see the answers. Maybe all have written D. So first option is 0.4 x1 plus 0.9 x2 plus 0.3 x3 plus 0.4 x4. So if you see that, so let's say it's a kind of lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 plus lambda 4 x4. So what is the sum of this all these lambdas? It is 0.4 plus 0.9, which is 1.3. Shall I go ahead? I don't require to, right? Because the sum should be equal to 1. Then only it can be a part of convex hull. But if you see that, what is the sum here? The total sum 7 and 11, 20. So 2, right? So sum of all these lambdas is 2, which is greater than 1, and uh, that is not fine. What about option B? If you see, I should reject this option B by looking at the first term itself, right? Why? Because the
Negative.
coefficient of x1 is minus 0.1 and it is negative. And what we said is each of the lambda should be positive, right? So first term itself is negative, so we have to reject it. What about option C? So yes, so all these lambdas are positive, definitely. But what is the sum of them? So 0.1 of x1, so that is 0.1. 0.1 square is how much? 0.01. 0.1 cube is 0.001 and 0.1 cube is again 0.001. And I know that the sum will not exceed 0.2 itself, right? It will be closer to point, how much it is? 112, right? It is 0.112. So it is the sum of these lambdas is not coming to be 1, and hence that this cannot be a point of convex hull. What about option D? If you see the sum, so 0.25 x1 plus 0.12 x2 plus 0.38 x3 plus 0.25 x4. These are the 4 points. So 0.25 plus 0.25 is 0.5. 0.38 plus 0.12 is again 0.5. So the sum is equals to 1. So it is actually covering all the points here. So definitely the question 3, the option D is the correct answer for the question D. Okay. Yeah, fine. Okay, let's see this question. This is slightly, I think the options here are wrong, I think. But whatever comes in your mind, you can just, maybe you can discuss it later. First place, you just have to write the correct answer, at least to yourself itself. Okay, so the question is, a storage shed is to be built in the shape of a box. So it's a square shaped box with a square base. It is to have a volume of 800 cubic meter. Okay, the concrete for the base costs 50 rupees per square meter. The material for the roof costs 70 per square meter, and the material for the sides cost 60 per square meter. What will be the constraint equation that is given to me? The options might be wrong. I'm not sure about it, but last time when we checked, that was wrong. But I'll try to show you what it maybe what is the question here, right? So this is a kind of a storage tank, right? Okay, right. And this is the roof of the storage tank, and this is the base of the storage tank. The height of the storage tank is h. Okay, and what is the base? Base is a square base, right? So the length of this square is x, and I think it is same for the roof. The only and what is the volume of this? 800 cubic meter. The question given to me is the storage tank volume should be 800 cubic meter. So I think that is a constraint to me. Uh, Another thing is the concrete for the base is 50 rupees per. So the cost for creating the base and the roof, right? It is different. Again, the side material cost is different. So you just have to imagine that figure which I showed to you and try to formulate a constraint equation here. I don't know whether this is correct option or not, but you just have to think about it. Maybe we'll discuss in a few minutes of time.
Option B should be 800, right?
Okay, I think only three of you have solved this problem. Maybe okay, I'll wait for 1 or 2 more minutes. What do you have to think about it is like here, what is the constraint? The maximum constraint is about about the volume of the tank, right? Or shed, whatever the shed is here. Uh, the limit is on the volume, right? So you have to think in that line. Maybe you'll get an answer, or you can just think about the cost also. You have to So Akash, please write your answer into this one, joinpeer.com, right? Or peer deck.
Sir, I did that.
Okay. Uh, okay, I'm not sure. Why is it that difficult? I don't see. Where are you guys facing any difficulties? Can you just tell me? That will be also fine. Uh, do you need more time, or you're not able to understand what it is? Is it okay if I solve the
Sir,
problem here?
option B should be 800, no?
Okay, so it's a constraint here, right? So if it is not 800, that means it's not correct, right? Whatever you're saying is correct. So the volume of the shade is what? H into x square, right?
8 into, yes, sir.
So, and that volume is given to me how much? 800. So that is
Yes, sir.
equal, right? So that is equality constant for sure, right? But if it
Yes,
is
sir.
not there, what does that mean? That's not a correct option.
Yes, sir.
Right. So there are two types of constraints, right? For any optimization problem. What are those two type of constraints? One is
Equality and inequality.
inequality. So here the equality constraint is which one? The volume one, right?
Yes, sir.
But according to the given options, it's not correct. So you have to think about any other constraint which can be possible by using this information also. So that hx square is equals to 800. How can we convert that into something else? So that also you have to think about. Think about in a way. Okay, I'll just give you the hint. It's about the surface uh, area, right? So what is the surface area of this kind of structure?
Sir, the sum of both the roof and base
Plus
and plus the sides, four
sides.
sides.
Yeah. So now you can think about it. And what should be the maximum surface area here?
200
How?
according to the option.
Right. So according to the option, but yeah, whether are you able to calculate it?
Sir, X is not given now. So how do we measure the surface area?
Sir, if we take it as a like cube, then considering x and h is equal, then we will get x as 20. So it should be 40, I guess, instead of 200.
So how do we get how we are getting 20 for X? All those are
Okay.
values. I mean the cost for the material.
Right. So, okay. Anyway, I said to you maybe that answer to this question is wrong, but okay. Let us maybe let us try to solve the problem. Okay. Will that be okay? Maybe we'll try to understand this one. What is given to
Yes.
me? The volume of this structure is 800 meter cube. So volume is actually is what here? It is x square into h equal to 800. Is that correct?
Yes,
Yes,
sir.
sir.
Right. So this one is equation one, and what else is given to me? The concrete for the base cost how much? It is 50 per square meter, and the material for the roof is 70 per square meter. Okay. So if it is 50 rupees for this part, this is how much? 50 rupees, and this is 70 rupees, right? So anyway, that is 120 rupees per square meter, right? So can I say that how much for roof and roof, how much cost it will occur for roof and this one base? It is 120 x square, right? That is
Yes,
okay.
Yes.
Okay. What about the sides?
sir.
So
It's 60
what is
rupees
the
per side.
per
Four
side?
sides, 4
And
into 60.
yeah, but what should be the area? You have to consider the area also, right? What is the surface
It's a
area here?
cube, so it's a square.
4 hx.
Huh?
4
So
hx.
4 into hx,
it's
right?
it
Right. So it will be 4 into hx into how much rupees? It is
60.
given to 60 rupees, right? So that will become 60 into 4, which is 240 hx. I hope all of you understood this. Okay. So maybe I'll just try to tell you that what is x square? X square is the uh, surface area of roof and base both, right? So this actually ideally this should be like this. For the cost of the base is 50 rupees into x square. The cost of the roof is 70 rupees.
they said it's a cube, so we can say x is equal to h.
It's not cube, right? It's kind of a cuboid. Where it is mentioned cube. There is no mention of cube, right? Anywhere.
Okay. Oh yeah, yeah, yeah. The
Yeah.
cube. Yes.
It's I think cubic meter, but
Yes, sir.
anyway, that is cubic meter is for everything, right? Yeah. And here it is how much? X into h is the area of the sides. So there are total of 4 sides into x into h. This is the area of one side, and there are my 4 sides, right? Into 60 rupees, and that is the total cost which can occur for this entire thing. Is that correct? Uh, so this will be 120 x square plus 240 x into h. This is the total cost, and this cost should be as low as possible, right? Is that correct?
Yes,
So
sir.
but we don't know how much on that side, right? But what I have the information here, x square h equals to 800 uh, meter cube, right? So can I just have h in terms of x or h something like that? Can we do that?
Yes, sir.
So what it will be then?
X square h equal to 800.
Sorry.
X square is equal to 800.
That is there already. So can I say that x square may be 800 by h or like that, right?
Yes.
Okay. But what is the surface? What is the so this is the volume, right? So can we have any relation between volume and surface area? Do we have anything like that? See, so x square is equals to it is actually equals to, let's say, x square is equals to 800 by h, right? So this is the equation we have already. Can we? Is it possible for me to connect it with the uh, rupees or something like that? Is it possible for me? That's the question here. So we have these 4 options, right? Which option seems nearly correct is option C, right? Not the D also, because you cannot say that it should be equal to some value. But can we come to this value somehow? Like maybe
How the C option C is right? I didn't understand actually.
No, no, that's not the correction. That's not the correct answer. But what it seems like, right? So most of the people have written that. But what do you think? Uh, okay, so maybe I'll just try to uh, show you
So
that. Maybe
equation in option C is the one which we want to minimize, right, sir?
no, no. These are the constants, right? So what is the question here? Question is
The
what will be the
equation given in option C is the equation which we want to minimize.
minimize, right? So that is the objective function actually, right?
Yes, and the constraint is given by hx square equal to 800. The constraint is given by hx square equal to 800.
800, right?
That is the
So
constraint which is given.
okay, right. So what is it actually? So this is the amount, right? Which is the so I should have the objective function f as what 120 x square plus 240 xh, right? And what should be my constraint? X square h or hx square equal to 800. Is that correct?
Yes, sir.
So this should be
Hello, sir.
the objective function. Yes.
Sir, oh, like what if we like consider different cases
Hmm.
for one where h is smallest, like in unit, so h equal to 1 and x is maximum,
Hmm.
and for the other one as x equal to 1 and h equal to maximum of the volume for
So
this.
what will happen then? So x
Then
hmm. What will be the values we'll get then?
then the vol like x square h is equal to 800. If I consider h as 1, then x square is equal to 800, so we will get the value of x, and since h is 1, so we get both the variables and we can write the inequality constraint value.
No, I think it's not like you cannot derive it, right? Like we don't know already, right? Here
Yes, sir.
we cannot assume it like h equals to 1 because here see what we have to minimize here in this question,
The cost
the cost for the like whatever
and
creating
uh,
that shade, right? So and that cost is coming how like what should be the like how we can make it into the equation as 120 x square plus 60 x square h, right? That is true.
yes, sir. Then we are getting the left hand side, but the right hand side it will depend on the options.
It's not left hand side, right? Like okay, what so when I said due to the general form, what is the general form? Do you have this function will have the left or right hand side?
Yes, sir.
No, right?
No, yes, no.
Correct, right? So when you have that objective function, there is some function. There is no equalities or inequalities associated with that. Is that correct? It is
Yes,
just a function. What we try to achieve is we try to find out the values of x and y such that the value of the function is minimum, right?
okay.
So I need to find the value of x and h, right? In this question, this function is what? This function is of these two variables x and h. I need to find the minimum values of x and h, right? So we do not have any kind of equalities or inequalities on that side, right? The only thing is we have this constraint which is hx square equals to 800. Keeping into that mind, I need to find out the values of x and h. Fine. You can make it to 0 or something else, that is okay. But generally how do you do that? If it is a function of only x, let's say x square, what do you do?
F dash x equal to 0, and we
0, but
get
then it is
the
yeah,
value
you
of
take a derivative, right? But
yes.
do you do anything here like with this x
No.
square? Like similarly, here we cannot do anything, right? It's a function. I need to minimize that function. Minimizing that function means what? I need to find out the values of x and h such that if I put it those values, they should not, they should give me the minimum value, right? And
Yes, sir.
suppose if I say that x and h, can I take x and h negative?
No,
No, right?
because
Because
they are
sides.
you
So
yes side.
x and h they are greater than or equal to 0, right?
Yes, sir.
This is what is also constraint, right?
Yes, sir.
So if you put some kind of constraints, so that now I wanted to find the values, right? So x should be greater than or equal to 0, and h should be greater than or equal to 0. And again, one more constraint is that h into x square is equal to 800. Right now, I wanted to find out the answer. So what are the ways to find it out? Now I cannot do, you know,
Sir,
find.
partial derivation.
You can do it, but again, it will not give you the it may not give you the answers. Right now, it will become a Hessian matrix and all. You have one
Yes.
more method, which is gradient descent method. Right? We have
Gradient
studied that
descent
also.
or
Right?
Newton's.
Yeah. So these are
What
the methods, right?
Yes, sir.
You have to follow.
sir,
Okay.
can I ask a question? What do you mean by the constraint equation? Is it the
Constraint.
objective? Is it the objective equation or the constraint itself?
No, it is a constraint. Okay. Let's try to see that if I have this function, right, x square and a,
No, in the question it is asked constraint equation. By constraint
this
equation, it is
uh,
asked constraint equation. What do
no
you
no
mean by
they
constraint equation? Is
constraint
it the objective?
no objective function. So I'm saying to you, right? So this is the wrong. These are the wrong options given there. Okay. So these are it. Basically, what should be the correct answer for this problem? If I ask what will be the constraint equation, it should
Hx
be hx square
equal to 800.
equal to 800, right? So now it is not there. What does that mean? These options are not correct.
So in
Fine.
the exam, if it is asked to the constraint equation, it means the constraint itself, right?
Yeah. There is
Not
no
the object,
any,
not the
no,
object.
no, no.
Okay, okay.
Right. So okay, that's okay. That is clear. What we try to think, like, at least we know now what is objective function or what is constraint, right? Constraint or constraint equation is the same thing. Fine. Okay. So the next question is what? In the previous problem, what will be our objective function? Now, what is the correct answer here?
Sir, A or C. Sorry.
Not A, it is C, right?
Yes, sir.
Because there is no Y. So it is 120 x square plus 240 xh. Now it is clear. So there was I think there is a typo here. I think it should be 800. Option B should be correct that point of time, but I think it was a mistake there. Fine. But here it's clear, right? What is the objective function? It's 120 x square plus 240 xh. And what we try to do here, and what does this objective function gives me? The cost required to create that shade, right?
It should be minimized.
Right, and it should be minimized. So my objective function here is minimize x and h such that uh, this function 120 x square plus 240 x into h, the cost has to be minimized. Fine. I hope it is clear to you. Okay. Okay. So let's go to the next question. Question number 8 is sorry 6 is which of the following is a convex function in R2? Right. So since they are all in two dimensions, right? Because there are two variables x and y. The question is which of the following are the or is a convex function in R2? How will you do? How will you find it out?
By making the Hessian matrix, sir,
Yeah. First of all, you have to find out the Hessian matrix, and this Hessian matrix has to be
uh,
positive,
positive semi-definite.
semi-definite, or positive definite, right? And if it is the case, then definitely that function is a convex function. Fine. Okay, so I can see here 5 responses. I'll wait for 1 more minute and then we'll see the problem, see the solution. Okay. Okay, so maybe I'll just look at the answers first. All 5 have responded to this. Okay, so let us see. I hope all of you know what is a Hessian matrix. If it is not, uh, what is the Hessian matrix? Let's say if the function is of 2 variables, suppose x and y. In that case, the Hessian matrix can be written as it's a partial derivative, right? Or second derivative del 2f by del x square. Here it is del 2f into del x del y. It's del 2f upon del y del x, and del 2f by del y del x is equals to what? Del 2f by del x del y, right? I hope all of you know that. And here it is del 2f by del y square. So the matrix in this format is called as a Hessian matrix. So in our question, the option A is what? The function is 2x square plus 2x square plus 5y square. So what is the Hessian? So what is the first derivative with respect to x? So del f by del x, the partial derivative is uh,
4x.
4x, right? Treating y as constant. Okay. What is del f by del y? So the partial derivative with respect to y, in that case, we have to keep x as constant. So it will be 10y. Okay. Now, what I need, but I need second derivative, right? So here it's del 2f by del x square. This is nothing but del by del x of del f by del x, right? And what is del f by del x here? So del by del x of del by del x is del f by del x is 4x. So it is equal to 4, right? And then del 2f by del x into del y is what? It is del by del x of del by or del f by del y, right? So I can use this. So del by del x of 10y. So here there is no x in here, right? So there is so we can treat a y as constant. So what is the differentiation of any constant with respect to any variable? That is equal to 0, right? So here it is 0. And what is it here? Del f by del y square. So similarly, I can find it out as del y of del f by del y, right? And del by del y of what is del f by del y? It is 10y. And what is the derivative with respect to y? It is 10. So if I put all these values into this equation, it will become 4, 0, 0, and 10. And what we said is, say this Hessian matrix has to be positive semi-definite. And what is the one of the ways of finding it out whether it is semi-definite or positive semi-definite or not is that determinant of h, right? It should be greater than 0, right? We have seen variety of things, right, about like how to find it out the definite positive definiteness of this matrix. I think while we are studying about SVD, uh, so that is one of the so it is one of the techniques, right? What is the determinant of h here then? It is 40, right? 4 into 10 is 40 minus 0. So determinant of h is equal to 40, which is greater than 0. That means this matrix is positive definite. So if it is positive definite, that means this function 2x square plus 5y square is what? Is a
1x.
convex function. Okay. Okay. Let us see about option B. And what is the option B? Option B is minus. So f of xy is minus 3x square minus y square. So I'll just directly find it out h now. I will not write down all the steps. So here it will be del 2. First of all, okay, let us find out all the values at least. So del f by del x is minus 6x, right? So minus 6x. So from here I can find out del 2f by del x square as minus 6. Del f by del y is minus 2y, and then del 2f by del y square it is minus 2, and del 2f upon del x del y it can be equal to 0, right? So h will be minus 6, 0, 0, minus 2. So the determinant here is
Positive.
positive, right? So which is so determinant of h is 12, right? But will that guarantee me? So which there are two determinants, right? So we told that there is this first determinant. So what are the determinants here for this matrix? They are minus 6 and minus 12. Sorry, plus 12, right? So if one of the determinants is also negative, then this is
Negative semi.
negative semi-definite. right? So if it is negative semi-definite, there are other you know uh, tests. One of the tests is eigenvalue test, right? So you can find out. So both the eigenvalues are negative, right? So I can say that they are it is negative semi-definite, right? Because it's a diagonal matrix, right? So hence this function is
Not one.
not a convex function. Okay, what about the third? Third is 2x square. So f of xy is 2x square minus y square. Okay, so Hessian matrix before. So del f by del x is 4x. Del 2f by del x square is 4. Del f by del y is minus 2y, and del 2f by del y square is minus 2, and del 2f upon del x del y is, I think it's 0, right? So okay, so the Hessian matrix here, it will be 4x, it will be 4x 0
Four,
0, sorry, 4 0 0 and minus 2. And if I see the determinant of h is minus 8, so it is already negative. So that means this is positive, sorry, negative semi-definite, right? And if it is negative semi-definite, that means it's not a convex function. Not a convex means what? It will be a concave function, right?
sir, is it this function? Is it negative semi-definite or indefinite?
Oh yeah, sorry. Yeah, I did a mistake. Yeah, if the determinant is less than 0, yeah, correct. So determinant, if it is less than 0, then definitely it is indefinite. Sorry, it is indefinite. Okay, if we but even in indefinite case, it's not a convex function, right? Yeah. Thanks for letting me know. So yeah, I forgot it. Okay, and option D is none of this, so it's not true. So which of the option is correct here? Option A is the correct option. And most of you, those who have written the answers, it's correct only. Okay. So this is the seventh question. Find the minimum value of the function x square plus y square plus z square subject to the constraint x plus y plus z equal to 1. So you have an objective function here. We need to find out the minimum value of that objective function. And the constraint is given to me as x plus y plus z equals to 1. Okay, first place, how will you find it out first? What strategy will you apply?
Lagrange.
Lagrange multiplier, right? And what is that condition?
Uh, the fx plus lambda times of this constraint.
Okay, that also you can do, or you can use the other one, which is professor has taught you, right? Maybe del f equals to minus lambda times del g, right? Is that you're familiar with that part?
Yes, sir.
You can use either of those, and you can find it out. Okay, fine. Just take your time and just solve it. So first of all, you have to find out the gradient of f, then gradient of the constraint equation, and then you have to solve it further. You have to equate it to minus. So you have to find out basically the values of Lagrange multipliers.
Hello, sir.
Okay, are you guys solving it? Shall I wait or let's shall we see the solution then?
Hello, sir.
Yes.
Sir, just one small doubt.
Hmm.
So this quiz 2, it will
Hmm.
be till week 8, na?
Wicket, yeah, till wicket.
Okay, sir.
Yeah, and majorly the portion will be from 5 to 8. Okay, so 5, 6, 7, 8 will be having the weightage.
Okay, sir.
Yeah. If you don't study for week 1 to 4 also, that's fine, not an issue with that. But at least you need all the concepts from week 3 and 4, right?
Yes, sir,
Yeah.
like the linearization and diagonalization and all
Yeah,
those.
all those things. Yeah. So basically, you'll have to know all those things too. But basically, the quiz questions will be coming from week 5 to 8.
Okay, sir.
Okay. Yeah. So shall we see the solution? I guess enough time is given. Maybe yeah. So the answers like yeah. So the question here is what? What is the objective function here? Uh, my screen is visible, right? Yeah. So what is the objective function? Uh, x square plus y square plus z square, right? X square plus y square plus z square, and we have to minimize such that these values we'll have to find it out. Okay. And what is the constraint given to me? Constraint is x plus y plus z equal to 1, right? The question is, what is the minimum value of the function? What to do? So, can you tell me what you have done? So, which method you have applied? I think one method is given in the tutorial. There is one method in the lectures, right? So, I think, and let us consider this equation as g. So, this equation can be written as like this, right? So, the method of Lagrange multiplier is this one minus lambda of del g, right? That is okay. So if I solve the equations coming out of it, I'll get the values for x, y, and z, and that will be the and by putting all those values into that function, we'll get the minimum value of the function, right? So what is del f here? It is del f by del x. So it's a vector, right? So vector of partial derivatives del f by del z by and del f by del z and minus lambda. Lambda is constant and it is called as a Lagrange multiplier also because you can formulate one equation, right? So that is okay. So del g by del x, del g by del x, del g by del y, and del g by del z. So this is another vector. So if I say for objective function, it is denoted by f. This is objective function, and what is this? This is a constant equation, right? Okay. So what is del f by del y del x? If I write here, sorry,
2x,
so
2y, 2z.
right, yeah. So it is 2x because when I partially differentiate f with respect to x, I'll treat y and z as constant. So to x square, the differentiation of x square will come as 2x. Del f by del y is 2y, and del f by del z is 2z, right? And what about this side?
1,
Uh,
1, 1.
so yeah, it's 1, 1, 1. Okay. So basically, I'll have to solve this equation. And what are these equations? So I'll get 2x equal to minus lambda, 2y equals to minus lambda, and 2z equals to minus lambda, right? Or can I say that which can be implied as x equals to minus lambda by 2, y equal to minus lambda by 2, and z equals to minus lambda by 2, right? So these are the 3 points on which I'll get this function's value as minimum value. What value should I put for lambda so that I can, or what should I do next now?
Constraint. Use the constraint.
What you should do?
Use G. Use G and plug the values of x, y, z in G.
In G, right? So what are, so what will happen to G now? G is what? X plus y plus z minus 1, right? So what will happen here? Minus lambda by 2. Okay. Minus lambda by, okay, maybe I'll write down G first. So G is what? X plus y z minus 1. Is that correct?
Yes, equal to 0.
Or maybe I can just put it like this. Okay, equal to
X
0,
plus
or maybe equal to 1, whatever. Already it is given to me, right, as a constant. So if I'll put all the values of x, y, z, and all are they are minus lambda by 2, minus lambda by 2, minus lambda by 2 equals to 1. So I'll get the value of, so here it will become 3 by 2 minus 3 by 2 lambda is 1. That means what is the value of lambda? Minus 2 by 3, right? Okay. So if lambda is minus 2 by 3, and then what is x? X is minus lambda by 2. So this is minus of minus 2 by 3 upon 2. So what is the value of x?
1 by 3.
1 by 3, right? What about y? Y will also become 1 by 3, and z will also become 1 by 3, because basically x, y, z are minus lambda by 2, right? So what are the values of x, y, and z now? So x is equals to 1 by 3, y equals to 1 by 3, and z equals to 1 by 3. So what is the minimum value of the function now? So what is the function? Function is x square plus y square plus z square, right? What should I have to do now here?
Plug 1 by 3.
Yeah, so whatever the values we have got here for x, y, and z, we'll have to plug it into this function, so that the value which will come out for this function will be the minimum value. So it is 1 by 3 square plus 1 by 3 square plus 1 by 3 square, and I think it is 3 times 1 by 9, which is 1 by 3. So the what is the minimum, and this 1 by 3 is a minimum value function, right? I hope it is clear to all of you. So you can just take a look at it once more. What we had this objective function, then we have this constraint equation. What we have to use? We have to use the Lagrange multiplier, and the equation to see that is del f equals to minus lambda times del g. Now by using that we got these equations, right? Equation 1, equation 2, and equation 3. So that these values of x, y, z I got in terms of lambdas. Now I have to find out the value of lambda. What did I do? I'll plug in all those x, y, z into the constraint equation, right? And by plugging in it, we'll get the value for lambda, and from that lambda we have found out the values of x, y, and z, and then these are the values which are the minimum values, or which are the values which can get me the minimum value of the function, right? And then I substituted all these values of x, y, z into the function's value, or into the function, and then I got what, the minimum value of the function. Okay, fine. So after that we are remained with two more questions. What is the boundary value of y so that the function x minus 3 to x minus 3 whole square plus y plus 1 whole square to remain convex? So what is the function given to me? The function is x minus 3 whole square plus y plus 1 to the whole square, right? This is a function. I need to find out the value of y so that the function remain convex. How to find out the, or when the function can be said to be a convex function? With two variables.
You have to calculate the Hessian here, sir.
Yes, yes. So you have to find out the Hessian matrix, and this Hessian matrix, uh, uh, if it is positive semi-definite, then I can say that it's a convex function. And then you have to check that that either that Hessian matrix is dependent on y, and what for what values of y, if I can change, right? So it will become the convex, right? So or it will remain convex, and for what values of y it will not remain convex. So that is the question asked here. Just solve it for 2 minutes, and then maybe I'll just jump into this and solve the problem. Okay, I can see the four responses. So there are three are saying which is option C is the correct option, and one is option uh, okay A. Okay, let's see. So this is the function, right? What is the Hessian matrix for this? So Hessian matrix will look like this: del 2f upon del x square, del 2f upon del x into del y, del 2f upon del x into del y, del 2f upon del y square, right? It's a symmetric matrix.
2002.
Right, okay, so if values are there, so I can just use, okay, let's say 2 into x, right? So this is 2, 0, 0, right? And this is 2y and 2. Okay, fine, that's okay. So this is 2 to the 4, right? So the determinant of h is 4, and whether this h or this determinant, right, equals to 4, which is greater than 0, whether this h, so definitely this is a convex uh, function, right? Given that it's a convex function, because this matrix H is a positive semi definite matrix, right? Uh, but is this determinant is dependent on any value of y?
No.
No, right? So that means for any value of y, this will remain convex, right? Suppose you had this function is like this, right? So it will become 4y, right? Now, if I asked you for what values of y, it will remain convex. So you can say that y should be greater than or equal to 0, right? That's correct, right?
Yes, sir.
So, but currently for your question, uh, this is not there, right? So that means this determinant is not dependent on the value of y, and what it can say to me, for all values of y, this function will remain convex. Another way of thinking this is what? This is a square, right? This is square and this is square, right? So, and this looks like a parabola, right? Upward parabola. So definitely it will be for any value of x and y, whether it is positive or negative, this will remain convex throughout, right? Okay. So some, okay, anybody has raised hand? Gur Simar, right?
Yes, sir.
You yeah, tell me
Sir, I
what
just
is
joined, so I don't know if you've discussed practice assignment questions, but I have one doubt in that.
practice assignment of week 9.
Practice assignment week 9. Yes, sir.
Okay, it's this is solved with the session, right? Maybe okay, after this question we'll take that down.
Okay, sir.
Right? This is the final question for this today's session. So after that, maybe I can take it out.
Okay, sir.
Okay. So question 9 is, which of the following Hessian matrix corresponds to the convex function? Just take 2 minutes to solve this, and then maybe I'll discuss that problem. Okay, let us see the answers. Maybe this is very easy to tell, right? So, first option itself, we can say that it's not a this Hessian matrix correspond. It will not correspond to a function, a convex function, right? Why? Because one of the values, right? It's pivot. The first pivot itself, which is -5 here in this case, is negative, right? So, and we do not need to go for the next option. Again, same for the option C. Option C also first pivot is negative, so definitely it's not a positive semi-definite matrix, and hence it will not correspond to a Hessian matrix of a convex function. Now it remains between option B and D. What is the determinant of that matrix B? The first determinant is 5, which is positive, that is okay. What is the 2 cross 2 determinant? Which is
14.
15 minus 2,
1.
15 minus 1, which is 14. So it is positive, right? So that means definitely it is this Hessian matrix correspond to a convex function. What about D?
It is also positive.
Yeah, so it is 15 minus 4, which is 11, and hence that also corresponds to positive to the convex function. So option B and D are the correct options, right? That's clear, right? I'm not solving
Yes,
it because
that's what
anyway
I was
we already have
confused.
solved like so many questions. Fine, yeah. Okay, so that's it from this solve with the slides. Somebody has asked me, I think Gursima, right? So he is having doubt from practice assignment question. Can you just tell me what is the question? Or maybe you can share your screen. We can see the screen and see uh, what is the doubt there. Gursimar, are you there?
Yes, sir. I'm finding the question once again. I'm
Sure,
on the
sure.
mobile, so I can't share my screen. So if you can open practice assignment week 9, or I can share my camera. I can open my camera because I have a laptop by my side.
Okay, 1 minute. Maybe I'll just open the portal and you can just tell me the question there. I'll share my screen. So give me a minute. It's from week 9 or which week?
Week 9 practice assignment.
Week 9 practice assignment. Question number
Question number 5.
5 is this one. X transpose X is a convex function, right?
Yes, sir. Yes, sir.
If function RD to R, when X transpose X is a convex function, if it's simple, right? Positive semi-definite or positive definite, both.
I
Both.
know, sir, the Hessian matrix has to be positive, definite, or semi-definite. So I don't understand what X transpose AX has to do with it.
Okay, X transpose X is what it will happen. So, okay, for any matrix X, right? Uh, this is not from this week actually. I think when we studied SVD, have you attended the class for SVD?
No.
No. Okay. So, okay, first place for any symmet. Okay, when we say for any matrix to be positive definite or positive semi-definite,
Uh-huh.
huh?
Yes. Positive definite is when all the eigenvalues are positive, and semi-definite is when they are non-negative.
Okay, but first place that matrix has to be a symmetric matrix, right?
Okay.
And if you think about Hessian matrix, it's always a symmetric matrix, right? Because
Yes.
and okay, suppose this is the matrix A B C C. Is this a symmetric matrix?
So which matrix are you talking about?
This one. Oh, my screen is not present. Just a minute. Okay, just a minute. Yeah. Now I think are you able to see my screen now?
Yes,
This
yes.
matrix A. CBB. So this matrix is symmetric matrix. Now there are four conditions to it, right? I think or maybe four tests. Which are those tests? Eigenvalues test that you know, right?
Yes.
So when we call it as positive definite or positive semi-definite, when these eigenvalues are greater than or equal to 0, right? When greater than 0, in that case, it is a positive semi-definite matrix, right? And it's a 2 cross 2 matrix in this case. So in that we know that there are only uh, two eigenvalues to this matrix, right? Okay.
Hmm.
What else condition is there? Determinant test. So what is the determinant test? A should be, so first determinant, this one cross one's determinant is A, it should be positive. Another is the whole determinant, which is AC minus B square should be greater than 0, right?
Yes.
Third test is what? Pivot test, right? And pivot test, so all the pivots should be positive. So first pivot is A, right? I hope you know it from the elimination method.
Yes. Yes.
And what is the second pivot? The second pivot will be this one, AC minus B square upon A, right? So, and that should also be positive.
Yes.
In that case, this matrix A has to say, we can say it as a positive definite matrix. What else is there? X transpose AX should be greater than 0 for positive definite, and for positive semi-definite, it should be greater than or equal to 0. And what is X transpose AX here? X is a any vector of two unknowns, right? So x1, x2, or maybe you can call it as xy, right? So let's say this is a vector. What is X transpose then in that case?
XY.
Xy, right? So you just think about it. If X transpose AX will be what? XY, right? Then A will be A, B, B, C, and here it is XY. What do you think? The resultant will be what?
A quadratic in XY.
It will be a quadratic equation, right? So it is a kind of a equation, right? Whatever equation it can be. So I'm just I'm just writing it as X transpose AX. So what it is saying in this question here is, suppose this equation, right, itself I'm calling it as X transpose AX. This is the function f, right, RD to R. And now let's say this is the function X transpose AX, and when this function will become a convex function, right? So that is uh, the I hope now you understood the question. So
Yeah,
now
I understood the question.
kind of a function. Now, when we call it as a uh, convex function, so I think if you just go back to again, right? If you try to find it out the roots, and again, what you do generally, you just try to find out the
The
Hessian matrix
discriminant
for
should be
this.
negative, right?
Yeah, or you can just try to find out what Hessian matrix for this function, right? That is what we do in this lecture, right? Or in this week, right? But I think it will again come out to be the fact that if this matrix A, if that matrix is positive definite, then what we can say that, see what will happen to this positive definite thing. This function will be a square function, right?
Yes.
Right. That means it will always be on the upward side. Is that correct? And when that will happen, when my A is positive definite, right?
Okay.
Right. So let's say this function is like this, x square plus y square, right? So this is it a convex function,
Yes,
right? Or x square plus y square minus, or maybe plus uh, xy square, is it a convex function?
it
Yes,
is.
correct. Right. So this in this case it is determined by using. So I can just say that instead of finding out this equation, I can say from A itself when that will be positive definite. So if A is positive definite, that means definitely this function X transpose AX is what? A convex function, right?
Yes.
Right. So that is what they have asked here. I hope it is now clear.
So A is directly related to the Hessian matrix of F.
You can say that way, or you can understand this process, because this X transpose X, right? Anyway, that function, if that function is so whenever you see that any symmetric matrix, if that matrix A is positive definite, right, or positive semi-definite, in that case what happens, this X transpose X is always what, is always a convex function.
Okay.
Are you so the implication is correct, right? When I
Yeah,
say
yeah.
that X transpose AX is convex function when A is positive definite or positive semi-definite, we are just
Yes.
using that fact to say that, okay, if this is and what is given to me, it's a convex function already. That means definitely A should be positive definite or positive semi-definite, right?
Okay, sir.
Right? Okay, I guess
Thank you.
that's Okay, guys, then that's it from week 9. Maybe if you have any doubts, because I'm sure that most of you are studying for quiz 2. So if any doubts are there for regarding week 9 or 10, maybe we'll take it in the next after quiz 2 again, right? Okay. Okay, guys, thank you for listening. Bye bye. Yeah.